Hello class, Tarmo here. I'm going to provide a quick tutorial today on making a adaptable calculator in Microsoft Excel. It's based on what I was mentioning in class this week about creating a tool that allows you to adapt to whatever question you throw at it to make sure that you get the calculation done correctly. So what I have here on the screen right next to me here, as my hand disappears into the ether, is one example. It's using the calculation for a Z value using CLT and thinking about having large samples. If you turn to your textbook on page 346, you'll see a worked example, and what I want to do is show you how we might want to set something like this up. My recommendation to you is to open a new workbook and create one sheet for each kind of calculator. Put some notes on each page that tell you when to use the calculator that you have on that page. Do you need to have a normal distribution? Do you need to know the population standard deviation? Do you need to have more than 30 samples? All of those questions that drive you to the right tool means that once you have the right Excel work page open, you have the right section of your textbook open, all you need to do is extract the right values from the question and put them into the calculator to receive the answer. So basically what I have on this slide is I have a graphic depiction of what the equation looks like. I'll show you how you can do this really easily using the tools that are embedded into Microsoft Excel, PowerPoint, Word, pretty much any of the Microsoft Office family tools, so that it becomes really easy to see what's happening. It looks like your textbook. This is what you could write into your submissions and so on. And I put some notes next to it so that I know what these things mean. So the denominator here, where we have sigma over root n, that is the standard deviation of sample means. It just means that I don't have to guess and try to remember what all of these symbols are. They're nicely written out here for me so that when I come to this page, I know what it is that I'm looking for or what key words in the question might relate to the kinds of things that this question requires. If I then dissect this entire equation here, I have a listing of all of the variables that are required for this system to work. We have x bar, mu, sigma, n, and z. Z is what we're calculating. I've highlighted it in green just to remind us that I need to find these values, whether it's by calculating them or extracting them from the question. But once I have them, then Z automatically calculates. It's possible to also write next to these things some notes on what these values mean, what they represent, and any parameters or assumptions that go along with them. The neat thing is, the way that I've set it up right now, imagine I had a question where the n wasn't 17. And what if it was 35? I could just type in 35 and hit enter, and notice that my Z value accommodates for that and adjusts accordingly. So we can go in here and change any of these. So maybe this is actually 23.8, and again the Z value adjusts. So this is what I mean by having a calculator. If I already know that the equation for calculating Z is properly inserted into Excel, and I can test it by looking at some of the worked examples in the textbook, putting in the same numbers, making sure that I get the same output, then I know that the equation is correct. Once that's correct and I need to use this calculator again, I can simply plug in the values and have it calculate the output for me, and I don't have to worry about whether or not I got the calculation formulated properly in Excel, because I've already done that previously. So let's take a look at, first of all, how this works in terms of a calculation, and then I will show you how to create this nice graphic depiction of what the equation looks like. So if I were to click on this cell, notice that up in the formula bar we can see the equation that is actually embedded inside that cell. I'm going to double click on here, and it brings it up right on the screen where it's easy to edit, and we don't have to go to the formula bar, but it also color codes all of the cell references, which makes it really easy to work with. Notice that all equations in Excel obviously always start with an equal sign, and then I use a series of brackets to group the numerator and brackets to group the denominator, so that when I have C8 minus C9 in brackets up here, I know that those are done as a set. We then have a division, and then a set of brackets. This one here corresponds to this far last one over here, and that is the denominator. So if I think about what the C8 and C9 mean, those are simply column and row references. C means column C, and 8 means row 8. So C8 is pointing to this cell right here, which is the value that I have for X bar. C9 is this cell here, column C, row 9, and it's the value for mu. And it's saying C8 minus C9. That means take this value that's in this cell and subtract from it this value that's in this cell right here. So if I go in and I change the value in this cell from 24 to 25, the equation still knows to go to the cell C8 and take the value from there, whatever it is, and it updates the equation accordingly. So similarly, we then have C10 divided by the square root of whatever's in C11. So C10 is sigma, and C11, which is currently hidden behind this editing screen, but if I hit escape and come back, we can see that C11 is this cell right here. The nice thing is these things are color coded, so if we look at C9, it's sort of that reddish orange color. Very quickly we see that it's this cell here. We can actually grab these cells and we can take that reference and move it somewhere else. And now the calculation says, oh, do all of these things regularly, but now take the value from F7, but it's empty, so it thinks of it as a 0 and it does nothing. But if I go in here and I put in the value 1, notice that the equation still updates because it's taking this value from well over here in F7. Well, the calculation tells me to do that. I don't really want that to happen, so I'm going to take this cell reference and I'm going to drag it back here to C9 where it should be, and I'm going to hit enter, and it's all back to normal. And really, that's all that's required. We have a listing of all of the variables, x bar, mu, sigma, n, and z. We have the ones that are required to be entered for the calculation to run, and then we have the equation for the value that's being calculated. And that is how we produce a calculator. We can verify that it works with numbers that we know and an outcome that we know, and then anytime we need to use this central limit theorem z-value calculator, we know that if we put the right numbers in, the calculation is going to be done correctly. Okay, so how do we then create this nice looking system over here? Give me 1 second, I'm going to slide it over behind me here, and I'm going to go over to Excel, and I'm going to go to the Insert ribbon, and all the way over on the right hand side here we've got a button that says Symbols. It might say Equation, but if we click on it, we can very much insert an equation. And it brings up what looks like a text box, but it has very specific options attached to it for putting information in about equations. So what I'm going to do is I'm simply going to type it the way that I see it. I start off with a Z, then I'm going to hit the equal sign, and the text here looks a little too small. It's a little bit hard to see, so I'm just going to highlight everything. I'm going to go back to the Home tab, and I'm going to change those to, let's say, 16-point font, and then I'm going to go back to the equation ribbon. So we now have Z equals. I'm going to use the arrow keys and go to the end of the equal sign, and I have to build the equation in sort of its basic structural form. And to start, I'm going to identify that there's a fraction where we have a numerator and a denominator. So if we go back to the equation toolbar, and I go to the end here, I can choose fraction, and I can choose the stacked fraction version. And now it's drawn the division line through the center, and then we have these dotted boxes, and these are placeholders that's telling me I need to put something in the numerator and I need to put something in the denominator. So let's start off at the top here. We need to put in x bar minus mu. The fact that the letter x has a bar over it is what's called an accent in mathematics. So we can go over here to the accent button, and we can choose the bar button. And now notice that it's put in the bar and a dotted box under it, which is a placeholder, and it's waiting for us to simply type in the capital letter X. And then we can hit the minus key and go over to our symbols and find the symbol for mu. And if I click to the side, you can see that we now have the numerator of our equation complete. We can then click back on here and say, well, let's fill in the denominator. The denominator is again a fraction because we have sigma over root n, but rather than having them stacked, they're drawn slightly more stylized. So we can do that here as well, where we go to fraction and we can choose the skewed fraction. We could use any of these methods of writing it. This one just kind of looks a little bit nicer. And we highlight the top placeholder, we choose the little more button, and we look up our sigma. And then in the denominator of the denominator, we are going to put in a radical, which is our square root sign, and then highlight the dotted placeholder box and type in the letter n. And there you have it. We can take this and move it wherever we would like. We can copy it, paste it into our Word document. We can incorporate it into text. We can draw arrows and point to things and explain what certain elements are. But we now have a tool to graphically represent what the equation looks like. And we have the way to describe how to build the, let me just move my screen here again, just out of the way a little bit. There we have the tool for making the calculator. So hopefully this helps. If you do this and you have one tab in each of the sort of sections of your textbook that you want to have calculators for, this is something that becomes really handy later when you want to reproduce some of the work that you've been doing. So good luck, and we'll talk to you again soon.